Hi guys, for today's lesson we're going to be dealing with the equations for linear lines, for straight lines. We're just going to be going over the basics today. So first up, horizontal lines, as basic as they get. They are lines with the equation of the form y equals a, where a is the y-intercept of the line. So for example, this horizontal line has a y-intercept of 3, so we call that equation y equals 3. Has this form, y equals something. This one here, horizontal, so it's going to be y equals. What does it equal? It equals the y-intercept of -1. Very similar with vertical lines, however, they have the equation of the form x equals a, where a is going to be your x-intercept. So this vertical line has an x-intercept of -4, so therefore it's x equals -4 for its equation. This one has a x-intercept of 3, so therefore the equation is x equals 3. Gradient intercept form. So this is the form for diagonal lines with equations of the form y equals mx plus c. So whenever you see this, you refer to it as gradient intercept form, because you have firstly, you have y as the subject, so y is by itself. That's a defining feature of the gradient intercept form, to have y as the subject. M represents the gradient of your line, and c represents the y-intercept. And remember, when you see a line like this, you can find your gradient from the rise divided by the run, as you see here, using 2 points on your line. And you can find your c from whatever the y-intercept is of your line. Okay, general form is another form for diagonal lines. So this and this both refer to diagonal lines, but this is of the form ax plus by plus c equals 0, where a, b, and c are random numbers. Note the coefficient of x, which is a, that is always positive. It has to be positive. And 0 is always the subject on one side of the equation. So it doesn't matter what b and c are, whether they're positive or negative, but a has to be positive and 0 has to be the subject on one side of the equation for it to be in general form. So let's do some example questions. So find the equation of the line that is parallel to y equals 3x plus 2 and passes through this point 0, 5. So what we need to think is, firstly, is that if it's parallel to this equation here, that means that they have the same gradient. The gradient here is 3 because it's in gradient intercept form. We can see the gradient is 3. So therefore the gradient of the line that we're trying to find, this equation, it also has a gradient of 3. We know that the m in our equation is going to be equal to 3 as well. We know that it passes through this point. This point is a y-intercept because the first number in this, the x coordinate is 0. Whenever x is 0, we know that we're on the y-axis. So therefore, our y-intercept is going to be 5. So we can put this straight into the equation of the gradient intercept form. We change our m to a 3 and our c to a positive 5. So that is our equation that we're looking for, that has these characteristics. Question 2, find the equation of the line that is perpendicular to this equation and passes through the origin. Okay, so if we know our line is perpendicular to this equation here, the gradients are going to be the negative reciprocal of each other. So this gradient of 3, we can use that to find the negative reciprocal because it's perpendicular. So 3 over 1 is the flipped, if we flip that and change it to, and we change the sign, it becomes 3 over 1 becomes 1 over 3, and the positive version becomes the negative version. So that is the desired gradient for this equation that we're trying to find. We also know that it passes through the origin, which means that its y-intercept, or c, is equal to 0. So we can put our information of gradient and y-intercept, we can put that into the gradient intercept form. Our m is -1/3 and our c is +0. That simplifies to this. You want to simplify these sorts of equations. So the x is multiplying by the top of the fraction. So 1 times x gives you 1x, and the negative stays put, so negative 1x. The 3 stays down the bottom, and plus 0, you don't need to show the plus 0 on the end. So this is the desired equation that satisfies these properties up here. Okay, moving on. Question 3. Find the gradient and y-intercept of the line 2x minus 3y plus 7 equals 0. So this is in general form because we've got 0 on one side and we've got a positive number for x. So the strategy is that if we change this to the gradient intercept form, that will show us what the gradient and y-intercept are, and that is exactly what we're trying to find. Okay, so change this to gradient intercept form by making y the subject. So we want to get this y by itself. Well, it's minus 3y at the moment. We can plus 3y to both sides to move this to the other side. So we get 2x plus 7 equals 3y. We can get y by itself by dividing by this 3. We do that to both sides. So 2x divided by 3 is 2x over 3. And 7 divided by 3 is 7 over 3. So we've got our y by itself. The coefficient of x is 2 over 3. So that is your gradient. And the plus 7 over 3 is going to be your y-intercept. And so that is the final answer. We've figured out what our gradient is and what our y-intercept is, which was what was desired. Okay, question 4. So find in general form, so that is where we have 0 on one side, etc., the equation of the line that passes through this point here and has an angle of inclination of 120 degrees. So the strategy is that we need to find the gradient and y-intercept of this line that has these properties. When we find the gradient and y-intercept for this line, we can then find the gradient intercept form, and then we convert this form into general form, which the question was asking for. So first up, it passes through this point right here. That means that the y-intercept is -2 because the first x, the x-coordinate was 0. So therefore we know this is on the y-axis. So we know that our y-intercept is -2. That means that our c is equal to -2. Now we can find our gradient using the angle of inclination, using this formula when we have the angle of inclination. So tan of theta is the same as our gradient. So our theta changes to our angle of 120 degrees. When we're finding tan 120 degrees, we think 120 degrees is in the second quadrant of the unit circle. That is where tan is negative, and the related angle with the x-axis is going to be only 60 degrees. Tan of 60 is equal to √3, and the negative comes down. So our gradient is going to be equal to -√3. We want to be using exact form as much as possible. We don't want the decimal version for this. It's too messy. So our gradient intercept form becomes this. Our gradient is -√3, and our y-intercept is -2. So they go on the end. Make sure you put your x and your y in the correct places. Now we need to change this to the desired form, general form. So how do we get 0 on one side and make the x-coordinate positive? So first up, let's get 0 on one side. We can take away the y from both sides. So we get that 0, because y take away y is 0, is equal to -√3x. The -2 comes down, and the minus y jots on the end. There are no like terms here to combine. Now we need our x coefficient to be positive. At the moment it's negative, so we're going to multiply everything by -1 to make it so it goes from negative to positive. So 0 times -1, that's 0. That becomes the positive version. This changes sign as well, so -2 changes to +2, and the y becomes positive y. Okay, we want to try and make this look a little bit nicer. We like to put the 0 on the right-hand side, and we like to have the x's go first, then the y's, and then the constants. So that is in perfect general form. Hope this helps with the questions.